Okay, today we are learning about functions. So let's get started with vocabulary. If you haven't already, please title this page 39 for your binder in the 2022 to 2023 school year. Okay, a function, before we hit function, let's talk about a relation, because a function is a special type of relation. So a relation is just a set of ordered pairs. Remember ordered pairs, we'll use a different color. Ordered pairs, that was nice. I don't want to say the word ordered pairs again. They're just the location of a point on a graph. The x value comes first and the y value comes second. That's the side to side number first and the up and down number second. Inside of parentheses, this shows us the location of an ordered pair, a point on a coordinate plane. So an example is this set of ordered pairs here. We've got 2, 3, 4, 2, 5, 7, 3, 0. Those are our 4 ordered pairs. It's a set of ordered pairs, so it's a relation. What we'll notice is that a relation, so that set of ordered pairs is contained inside of those curly braces. That just means these curly braces, the curly braces just mean it's a set. So it's just a list of objects. That is just set notation. So the set is on the inside of those braces. So here's the set, and that's just a list of ordered pairs. So this is a set of ordered pairs. A set of ordered pairs is a relation. Okay. A function is just a special type of relation. So it's ordered pairs that are special. It's when you have a list of ordered pairs where where there's exactly one y value for each x value. So this is the one that I want you guys to memorize, which is why it's in all caps. Each value of x is associated with a single value of y. So we are only going to look at the x. In other words, every x value is used just one unique time. When I say unique, I mean it's used once with its own individual y value. It doesn't have any other y values. A non-example of a function is called a non-function. And that happens when an x value has more than one y value. Okay. If you have been taking notes on this, you might want to pause the video for just a moment and catch up on the writing. Okay? To see if a relation is a function, you need to do two things. First, you're going to cross out any identical ordered pairs, and then you're going to ask the question, does each x value appear just once? So you ask that question only after you've crossed out any identical, so the exact same ordered pairs. So let's look at some examples. And I'm just going to skip down to the example in the third row. So this is the first row. You don't have to write this, please. The second row. And the third row. Okay, I don't want you guys to think you don't have to write anything. Now you guys can write down what I write. The very first thing we were told to do to see if a relation was a function, and that's what the instructions are here. was cross out any identical ordered pairs. So in the third row in the middle box, we can see that the ordered pair 1, 0 is used more than one time. So we're just going to cross out the second ordered pair because we've already got it listed. The second thing we do is ask, does each x value appear just once? So since we're asking a question about the x values, we should know what the x values are. So we're going to circle the 1 because it's the x value in the ordered pair 1, 0. We'll circle the 2 because it's the x value in the ordered pair 2, 1. And we're going to circle 4 because it's the x value in the ordered pair 4, 1. So the x values then are 1, 2, and 4. The question we have to ask is each x value used just once? The answer is yes. So this is a function. This relation is a function. Good. Now let's go back to the first row and look at some of these other examples. So the very first thing we were asked to do is cross out any identical ordered pairs. That's something that has the same exact x value and the same exact y value. So here I've got an ordered pair 1, 2. I have the ordered pair 3, 5. I have the ordered pair 5, 7. The ordered pair 4, 8. And the ordered pair 9, 8. None of those ordered pairs are identical to each other. So now I can go ahead and ask the second thing. Or go on to the second step where I ask the question, does each x value appear just once? So I should know what the x values are. The x values are 1, 3, 5, 4, and 9. Each of those x values appear just one time. So I would say yes, this relation is a function because every x value appears just once. Okay. Looking at the one to the right of that, we first cross out any identical ordered pairs. The ordered pairs we have, go ahead and try to underline them on your own. We underlined the ordered pair 2, 3, 1, 5, 5, 8, 1, 0, 4, 7. We've underlined 5 different ordered pairs. None of them were identical, so I don't cross out any ordered pairs. Now I ask the question, does each x value appear just once? So I need to know the x value. The x value is more than one of them. So does each x happen just once? The x values are 2, 1, 5, 1, and 4. So I see that the x value, 1, happens more than once. So the answer to that is no, which means this relation is not a function. Okay, looking at, I want to keep an eye on the time that I'm using. There we go. Okay. Looking at the example to the right of that, so we're first going to underline all of the ordered pairs that we have in this relation. This makes a relation, or a set, and it's a set of ordered pairs, so this is a relation. The ordered pairs are 1, 1, 2, 1, 3, 1, 4, 1, and 5, 1. None of those are identical ordered pairs. They're not the same exact thing. So what we're going to do is ask the question. Now we can skip to the next thing, the second thing. Ask the question, does each x happen just once. Remember, x values are the first thing in the ordered pair. So we're looking at the very first number in the ordered pair. The first number in the ordered pair 1, 1 is 1. The first number, or x coordinate, in 2, 1 is 2. The x coordinate in the ordered pair 3, 1 is 3. And the x coordinate in 4, 1 is 4. The x coordinate, or the first coordinate, in the ordered pair 5, 1 is 5. So even though there was a whole bunch of 1s in this problem, every x value was associated or corresponded to a single y value. Each x value, 1, 2, 3, 4, and 5, only occurred once. So yes, this relation is a function. Okay, maybe pause the video and catch up on writing. Okay, hopefully you're caught up on writing, and I think we've kind of got the first 2 steps down. First, we cross out any ordered pairs that are identical or the same as each other. We only need to cross out one of them. And then you ask the question, does each x value occur just once or appear just one time? Okay, so looking in the second row, we're going to, first I see that this is a set because of the set notation. And inside of this set is a list of ordered pairs, so I know that this is a relation. The ordered pairs that I see in this relation are 1, 2, 2, 3, 2, 4, and 3, 5. None of those are identical to each other, so I don't have to cross anything out. And now I'm going to ask myself, does each x happen just once? Each x. That's going to be sloppy. Each x happens just once. The answer to that would be, well, let's look at the x values. In the ordered pair 1, 2, the x value is 1. In the ordered pair 2, 3, the x value is 2. In the ordered pair 2, 4, the x value is 2. In the ordered pair 3, 5, the x value is 3. So those x values, some of them are occurring more than once. X equals 2 happens more than once. So the answer here is no. X equals 2 happens more than once. So this relationship, this relation is not a function. It's not a function. At the start of the notes, I said that this was the sentence we kind of wanted to pay attention to or memorize even, where each value of x is associated with a single value of y. So the value of x, where x is 2, in the problem that we just looked at, the value of x equals 2 is associated with or belongs with more than one y value. Those y values are 3 and 4. So because of that, this is not a function. Looking at the next relation, I know it's a relation because it has the set notation, and inside of the set notation is a list of ordered pairs. Those ordered pairs are 1, 2, 1, 3, 1, 4, and 1, 5. There are some repeating numbers, but none of those ordered pairs are exactly identical with both the x and the y value. So I don't cross anything out. And now I'm asking myself the question, does each x occur just once? In order to answer that, I've got to know what the x values are. So I'm going to highlight the x values. If you don't have a highlighter, you can circle them. We've got in the ordered pair 1, 2, the x value is 1. In the ordered pair 1, 3, the x value is 1. In the ordered pair 1, 4, the x value is 1. And in the ordered pair 1, 5, the x value is 1. So we can see that there's a lot of repeating x values. So the x value 1 is associated with a 2. It's associated with a 3. It corresponds with a 4. It matches with a 5. So each x value has more than one y value. The x value x equals 1 has too many y values. The x's happen more than once, not just once. Those are all a lot of different ways to say that no, this is not a function. This relation is not a function. Okay. Go ahead and pause the video and identify the ordered pairs in this second row, third problem. Identify the ordered pairs. So pause the video and identify the ordered pairs. Okay, hopefully you paused the video. The ordered pairs are 1, 1, 2, 2, 3, 3, and 4, 4. Now pause the video one more time because you're about to answer the question, does each x value happen just once? So pause the video and identify the x values. Okay, I hope you paused the video and then identified the x values. Remember, x values are the first number in the coordinate. So that's 1, 2, 3, and 4. That's the 1, 2, 3, and 4 on the left side of the ordered pair. Oh no, it's dark now. Give me a moment. Okay, I'm back. All right, does each x value happen just once? So you identified the ordered pairs as 1, 2, 3, and 4, and those were on the left side of the ordered pair, not the right side, because the x values are on the left side. So you've asked yourself now, do the x values occur just once? You've got 1, 2, 3, and 4. The answer to that is yes. So this is a function because the x value 1 only has one different y value. The x value 2 only has one different y value. The x value 3 just has a single y value, and the x value 4 has a single y value. So yes, this is a function. Each x is associated with or belongs with a single y value. Okay. I can feel it in my bones. Some of you are saying, how come I can't just say, yes, the relation is a function? I want you to write this sentence because often when we talk about functions, this is the vocabulary we use. So yes, you have to write this. You have to write the sentence that I just wrote. This one right here. Go ahead and pause the video and make sure you write that down. This sentence, please. Yay, you've paused the video, and I know you wrote that sentence. Like good 8th graders do. They do everything their teachers tell them to do. Okay, I'm going to try and wrap this up, so we'll just finish out the third row, and then I'll give you the answers to the final row, just in case you want to do some math for fun on your own, and you want to check your answers on that. Okay, so let's look at identifying what the ordered pairs are in this relation. We have the ordered pairs 1, 3, 2, 3, 3, 3, and 4, 3. None of those ordered pairs are repeating themselves. They're not identical. So now I get to just move on and ask myself, does each x value occur just once? Well, the x values are 1, 2, 3, and 4. Since each x value occurs just once, I would say yes, this is a function. But instead of writing yes, this is a function, let's write out the fancy vocabulary way, the fancy way to say that this is a function. So this is a function. Every x corresponds with one y value. You could have written the exact same thing we had in the problem before this. Each x is associated with a single y. I just wrote it this way instead. They mean the same thing. Correspond means it matches with it. So 1 matches with 3, 2 matches with 3, 3 matches with 3, 4 matches with 3. This is a lot of 3's, but we don't care about the y value repeating itself. We care about the x value repeating itself. Okay. I said we were going to finish out the middle row, and I think I lied. Go ahead and we're going to cross that example. Oh, you don't have to cross it out. Instead, I'm just going to give you the answer. My bad. Okay, 3, 2, 1, 4. So yes, this is a function. The next one, yes, this is a function. Middle one, 9, 3, 7, 8, 6, 1, 5, 0, 6, 9. Yes, this is a function. Now let's look at the very last one, the very last box. So we first need to identify what are the different ordered pairs. So we've got 3, 9, 3, 8, 5, 8, 7, 9, 1, 3. None of those are identical ordered pairs, so I don't have to cross anything out of my list. So what I'm going to do now is ask, does each x value happen or occur just once? So now I'm looking at what the x values are. That's the first number in the ordered pair, 3. The x value in 3, 8 is the first number, 3. The x value in the third ordered pair, 5, 8, is 5. The x value in the ordered pair, 7, 9, is 7. And the x value in the ordered pair, 1, 3, is 1. Okay, so we can see that the answer to that, does each x happen just once, is no. Because x equals 3 is associated or belongs or matches or corresponds. X equals 3 is associated with 9 and with 8. So with 2 y values. And it's only allowed to associate or belong with 1 y value. That is it for today's notes. If this does not make sense, please send me a Schoology message. I will get back to you as soon as I can. You could also, you have all the ways to contact me. Your assignment is on Schoology. It should be titled Functions Day 1. I think some of you have already opened it. Unless you made a 100 on it, I would like you to go back and reattempt it now that you've had the lesson. Thank you. Bye.